November 25, 2024. Douglas McGregor releases Taking Nazi Technology with Johns Hopkins University Press. The National Interest writes, America systematically stole German war technology. But it wasn't just America. Today, in 2025, China is manufacturing the Type 67 hand grenade. Take a good look at the design. A stick, a metal head, exactly like the German Stielhandgranate M24 from 1915, 110 years later, identical. The Soviet Union copied it in 1930 as the RGD-33. China copied the Soviet copy. North Korea copied the Chinese copy of the Soviet copy, 4 generations of copies, all based on a German design from 110 years ago. Today, I'm going to show you the documented tech lineage from 1915 to 2025. Picture this. It's March 1915, Western Front, Ypres, Belgium. British soldiers in trenches are throwing Mills bombs, spherical, weighing 680 grams. Maximum throwing distance, 15 meters. That's the reality. You can only hit the enemy at 15 meters, but its own fragmentation range is 20 meters, which means when you throw, you have to duck immediately. Your own grenade puts you in danger. Then, May 1915, the Germans show up with something completely different. The Stielhandgranate model 1915. Soldiers called it the potato masher, a 30-centimeter long wooden stick, a metal head with explosives on top, weighing 600 grams, lighter than the British one. But the throwing distance, 30 to 40 meters, twice as far. This isn't a minor improvement. This is a revolution. The physics are simple. Take a ball, throw it. Your wrist gives it energy, maybe 15 meters. Now take a hammer with a long handle, throw it. Your whole arm becomes leverage. The stick extends the throwing radius. More leverage means more speed, which means more distance. German engineers understood this physics in 1915. The stick grenade wasn't a random shape. It was applied mechanics, the law of levers. Every physics student knows it. But only Germany built it into a hand grenade. The M24 was an improvement on the 1915 model. Introduced in 1924. M stands for Model, 24 for the year. The specs: overall length 35.6 centimeters, head diameter 6 centimeters, stick made of wood, mostly birch or beech, head made of sheet steel. Explosive charge 165 grams of TNT in the sheet metal container, detonator inside the stick with a pull cord. Burning time 4.5 to 5 seconds, fragmentation effect 10 to 15 meter radius, but throwing distance for an average soldier 30 to 40 meters. Trained throwers could manage 50 meters, compare that to Allied grenades in 1939, the British Mills bomb 680 grams, 15 meters throwing distance, the American Mk2 pineapple grenade 600 grams, 15 to 20 meters. The French F1, 600 grams, 15 meters. The Soviet RG-42, 420 grams, 25 to 30 meters. Only the RG-42 came close to German performance. Why? Because the Soviets had already copied the stick shape in 1930 with the RGD-33. They understood. The Germans were right. Production of the M24 began in 1924 and ran until 1945. Estimated total production, 75 to 80 million units. That's not a rough guess. German war production files document it. In 1944 alone, 30 million pieces. Per month, 2.5 million. Per day, 80,000. Every minute, 55 stick grenades left German factories. The production cost per piece, 0.40 Reichsmark in 1924, dropped to 0.28 Reichsmark in 1944 through mass production. That corresponds to about 2 to 3 euros today. Cheap, simple, deadly. The construction was ingeniously simple. The soldier unscrewed the metal head. Inside was a porcelain ball at the end of a cord. He gave it a sharp pull. The ball broke a friction igniter. The igniter activated a delay charge, 4.5 seconds. The soldier threw. The grenade flew. Impact, explosion. 165 grams of TNT detonates at 6,900 meters per second. The metal head tears into hundreds of fragments. The pressure wave kills up to 2 meters. Fragments kill up to 10 meters. Injury effect up to 25 meters, but there was also a second variant. The Revolutionized 39, the smoke grenade, same stick design, but instead of TNT, a smoke generator, and a third. The practice grenade, black head instead of grey, no explosives, just a bang charge. Soldiers trained with real weight and real throwing mechanics, without danger. That was systematic combat training. No Allied army had comparable practice grenades in such large numbers. The psychological effect was immense. British and American soldiers reported the sound was unique. A thrown Mills bomb makes a quiet whistle. A stick grenade makes a deeper, rotating sound. The stick acts like a flight stabilization fin. The grenade flies more stably, straighter, predictably. This meant German soldiers hit more often. British reports from Monte Cassino in 1944, German grenade throwers had a 30 to 40% higher hit rate than Allied throwers. That wasn't just better training alone, it was a better tool. The throwing distance fundamentally changed tactics. With 15 meters, you have to get very close to the enemy. You put yourself in extreme danger. With 40 meters, you attack from a safer distance. You can throw over obstacles, into second-story windows, over walls, into tank hatches from farther away. The stick grenade wasn't just a weapon, it was a tactical multiplier. Let's take a documented example. Stalingrad, November 1942. Street fighting, close combat, house by house. German assault troops used an average of 8 to 12 stick grenades per soldier per attack. Soviet reports document Germans could throw grenades from 40 meters into windows. Soviet RGD-33 stick grenades had a similar range, but Soviet F-1 Lemon grenades only 20 to 25 meters. German and Soviet stick grenade users had a tactical advantage. Why? German design from 1915. The Allies recognized the problem. American Aberdeen Proving Ground reports from June 1943. Tests with captured stick grenades. Result: average GI throws the M24 38 meters. The same person throws the Mk2 Pineapple 22 meters. 73% range increase. The physics are irrefutable. The test report recommended USA should develop stick grenades. It never happened. Why? Production lines were already established for the Mk2. Millions produced. Conversion would cost too much. So American soldiers continued to throw with a 40% disadvantage. The British tested it too. Woolwich Arsenal, August 1944. British soldiers threw the M24 an average of 41 meters. Mills bombs, 17 meters. The report concluded, stick form is superior for range, but Mills bomb has more fragmentation effect due to rifling. British conclusion, keep Mills for defense, develop stick for offense. It never happened. The war ended first, but one nation listened, the Soviet Union. They had already learned those lessons by 1930. Let's take a look at exactly what happened. 1914 to 1918, World War I. The German stick grenade, the Stielhandgranate of 1915, dominated the trenches. Russian soldiers experienced it firsthand. After the war, the Red Army analyzed captured German weapons. 1930, decision: develop their own stick grenade. The result? The RGD-33. RGD-33 specifications: overall length, 36 centimeters, almost identical to the M24. Wooden handle, metal head, explosive charge, 120 grams of TNT, slightly less than the Germans' 165 grams, weight, 500 grams. Throwing range, 30 to 35 meters. The shape, an exact copy of the German stick grenade. Soviet military records from the State Archives released in 1991 confirm it directly. The design is based on the German stick grenade captured in 1918. Production of the RGD-33, 1933 to 1940, an estimated 6 to 8 million units. Then, in 1940, replaced by the RGD-5 ball grenade because of simpler production. But the concept remained. The Red Army had learned. The stick form works. Physics is physics. A lever is a lever. The Germans had been right, but the story continues. 1950s, the People's Liberation Army of China. After the Korean War, China analyzed Soviet weapons. They discover the RGD-33. They discover the stick principle. 1959 decision, develop the Type 67. Take a look at the specifications. Overall length, 33 centimeters. Wooden handle, metal head. Explosive charge, 38 grams of TNT. Defensive version, steel fragmentation. Offensive version, smooth head, only pressure wave. Throwing range, 30 to 40 meters. The shape, identical to the M24 and the RGD-33. The Type 67 has been produced from 1967 to the present day, 2025. 58 years of continuous production. Estimated total production, 100 to 120 million units. That's more than all German M24s combined. China exports the Type 67 worldwide. North Korea licenses production as the Type 68. Vietnam produces a copy. Pakistan produces a variant. Albania, Romania, Cambodia. At least 12 countries produce variants of the Type 67, all based on the RGD-33, all based on the M24, all based on the German design from 1915. Let's delve deeper into the Type 67 variants. The offensive version, the Type 67 Type 1, has a smooth metal head, no serrations, no fragmentation, only TNT detonation. Why? For assault. Offensive grenades create a pressure wave without shrapnel. The attacking soldier is close. Shrapnel would endanger him. The pressure wave directs itself forward, safer for the thrower. Kill radius 5 meters, pressure wave 10 meters, stunning effect 15 meters. The defensive version, the Type 67 Type 2, has serrations on the outside of the metal head, like a pineapple. Pre-made breaking points. Upon explosion, the head tears apart along these lines. Hundreds of steel fragments. Radius, 25 meters. Kill radius, 10 meters. This grenade is for defense. The soldier throws from cover, trench, bunker, building. Fragments hit attackers. Defender is protected. That's the identical concept as the German stick grenade of 1915. Offensive versus defensive variants. China didn't just copy the shape, they copied the entire tactical philosophy. Documented combat use of the Type 67. Vietnam War, 1965 to 1975. The North Vietnamese Army and Viet Cong used an estimated 5 to 8 million Type 67s. American combat reports mention stick grenades constantly. Battle of Ia Drang, November 1965. NVA threw Type 67s from 40 meters distance into American positions. M26 grenades of American GIs only reached 30 meters. Tactical disadvantage. Operation Cedar Falls, January 1967. Tunnel warfare. Viet Cong preferred Type 67 offensive variants. No shrapnel in the confined space, only pressure wave. Effective and safe for their own troops in tunnels. Afghanistan, Soviet invasion 1979 to 1989. The Soviets supplied RGD-5 ball grenades to the Afghan government. Mujahideen captured them. But China supplied Type 67s to the Mujahideen via Pakistan. CIA reports, released in 2019, document 2 to 3 million Type 67s delivered 1980 to 1989. The Mujahideen preferred them. Throwing range, 40 meters, from mountain positions into Soviet convoys below. Tactical advantage in mountainous terrain. Height plus stick lever equals extreme range. Some reports mention 50 to 60 meter throws from cliffs. Syrian civil war, 2011 to the present. Various factions use the Type 67. Chinese exports from the 1970s and 1980s, stored in Syrian depots. The Free Syrian Army captured thousands. ISIS captured thousands more. The Kurdish YPG received new deliveries from China via Iraqi channels. Combat videos show the Type 67 in Aleppo, Homs, Raqqa. Urban combat. Grenades thrown from buildings into streets. The stick form allows throwing around corners. Swing the stick, the grenade flies in the desired direction. Ball grenades roll uncontrollably. Stick grenades fly precisely. Myanmar Civil War 2021 to 2025. The Tatmadaw military government uses Type 67s supplied by China. Ethnic rebel groups produce their own copies in jungle factories. Improvised stick grenades, PVC pipe as the handle, tin can as the head, black powder as the explosive. Primitive copies, but the principle works. A lever is a lever. Even improvised stick grenades reach 25 to 30 meters, more than improvised ball grenades with 15 to 20 meters. German physics from 1915 validated in jungle factories in 2025. Let's compare fragmentation patterns. The M24 German grenade. The metal head tears apart irregularly. Fragments of various sizes, 10 to 200 gram pieces. Unpredictable, deadly, but inefficient. Type 67 defensive version, pre-made serrations. Fragments of constant size, 2 to 5 gram pieces. Predictable, deadly, and efficient. China improved the German original. Modern manufacturing allows precision. Result, the Type 67 defensive has 30% more fragments with the same metal weight. The Germans could have done this in 1944 if they had production capacity. They didn't. China in 1967 did. Production methods comparison. M24 in 1944, wooden handle turned on a lathe, metal head stamped and welded, TNT hand poured, fuse hand assembled, labor intensive, 12 labor hours per 100 grenades, Type 67 in 1975, wooden handle machine milled, metal head pressed in one step, TNT machine poured. Fuse automatically assembled, 2 labor hours per 100 grenades, 6-fold efficiency, same grenade, more modern production, Type 67 in 2025, fully automated lines, handle made of plastic composite material, injection molded, metal head robot welded, TNT computer controlled dosed. Fuses assembled by machines, 0.3 labor hours per 100 grenades, 40-fold efficiency compared to 1944. That explains why China could produce 120 million. The German war economy in 1944 managed 30 million with enormous effort. China's peacetime economy in 2025 creates 120 million on the side, but the shape is identical. Stick plus head, 110 years unchanged. That proves it. The design was optimal. If you produce something for 110 years without fundamental change, the original was right. Modern materials changed production methods. Modern manufacturing increased efficiency. But the physics remained the same. A lever works in 1915. A lever works in 2025. The Germans understood physics better than almost anyone else. Let's talk about the irony. Germany invents the stick grenade in 1915, loses World War I in 1918. The Treaty of Versailles prohibits many weapons, but the design endures. In 1924, the Weimar Republic develops the M24 for the Reichswehr, a 100,000-man army limited by Versailles. Nevertheless, they developed the best hand grenade in the world. In 1933, the Nazis seize power and begin mass production of the M24. From 1939 to 1945, World War II, 75 million M24s produced. Germany loses again. In 1945, the Soviets and Americans capture millions of stick grenades, Aberdeen Proving Ground tests them, Kubinka tests them, both reach the same conclusion: superior design, but only the Soviets acted on it. America stuck with the Mk2 pineapple grenade, Britain the Mills bomb, France the F1, only the USSR copied it. And China copied the copy. And today, in 2025, a Chinese soldier throws a Type 67. The physics are identical to 1915. The lever is identical. The range is identical. 110 years of technological stagnation. Why? Because the Germans found the optimal design in 1915. Physics doesn't change. The laws of leverage are universal. The stick grenade was, and is, the most physically efficient solution for maximum throwing distance. Now comes the interesting part. What happened to the German design after 1945? How exactly did it spread? And why doesn't the modern Bundeswehr use stick grenades anymore, even though they invented them? May 1945. Germany surrenders. Allied troops occupy the country. In factories, warehouses, military depots, they find millions of stick grenades. American units alone confiscate an estimated 15 to 20 million M24s. Soviet troops, another 10 to 15 million. British and French units, millions more. What happens to these grenades? Operation Paperclip, an American program to recruit German scientists and technology. We know the famous cases, Werner von Braun and rocket technology, but it was much broader. The Joint Intelligence Objectives Agency created lists. CIOS, the Combined Intelligence Objectives Subcommittee, catalogued German weapons. Fiat, the Field Information Agency Technical, wrote reports. For stick grenades, CIOS Report Geschichtwas 105. Title: German Stick Grenades Design and Production Methods, 78 pages, published September 1945, classified until 1973. What was in this report? Complete manufacturing instructions, material specifications, types of wood, metal alloys, explosive formulations, fuse mechanics, production rates, cost breakdowns, quality control procedures, everything. The Americans copied all the German knowledge, but they never produced their own stick grenade. Why not? NATO standardization. In 1949, NATO is founded. 1950s. Efforts towards standardized equipment, hand grenades, a debate between stick and ball, the American position, the Mk2 pineapple. Grenade is the standard, the British position, the Mills bomb, the French position, the F1, the German position. We'd like the M24 back. NATO decision, the ball type becomes the standard. Why? Transportation and storage. A ball grenade is compact. A soldier carries 6 to 8 in pockets and on his belt. A stick grenade is long, difficult to carry. A maximum of 3 to 4 per soldier. NATO chose compactness over range. But look at the numbers. The modern NATO standard grenade. The American M67, weight 400 grams, throwing distance 30 to 35 meters. Wait a minute. That's the same range as the M24. How is that possible? Shouldn't a ball shape fly a shorter distance? The answer: the M67 is lighter. 400 grams instead of 600 grams for the M24, or 680 grams for the Mills. Lighter weight compensates for the missing lever. The physics doesn't change. To achieve a 35-meter range with a ball shape, they had to reduce the weight by 33%. The Soviet Union took a different path. They had the RGD-33 from 1930. They knew the stick form works, but they also had a problem: production. A stick grenade needs wood, metalworking, screw threads. A ball grenade is simpler. Casting, filling, sealing. In 1940 they introduced the RG-42, a ball shape, but they retained the RGD-33 concept for special applications. The RGN offensive grenade, smooth head, just impact. The RGO defensive grenade, fragmentation, both with optional sticks for longer throwing distance, modular design. Use the stick if you need range, remove it if you need compactness. China watched both, NATO ball grenades, Soviet modular grenades. In 1959, they make a decision, pure stick form, the Type 67. Why? The People's Liberation Army doctrine was based on massive infantry, millions of soldiers, limited transport capacity. They needed simple, cheap, effective weapons. The Type 67 met all the criteria. Production cost, 50 cents USD equivalent in 1967. Today, maybe $2. Wooden stick from local trees. Metal head from recycled steel. TNT from simple chemistry. Throwing distance, 40 meters. Perfect for Chinese needs. From 1967 to 1980, China produced an estimated 50 million Type 67s. Exported to North Korea, Vietnam, Cambodia, Laos, Pakistan, Albania, Romania, various African countries. Vietnam War, the Viet Cong and NVA used the Type 67. American soldiers reported, "Charlie throws further than we do." The American M26 grenade, 25 to 30 meters. The Type 67, 35 to 40 meters. Again, the stick form had the advantage, 52 years after the German invention. But here's the biggest irony. In 1956, the Bundeswehr is founded, West Germany is rearmed, a NATO member. They need hand grenades. The logical choice, the M24 stick grenade, a German invention, a proven design, unmatched range. NATO says no. They have to use the NATO standard DM51, a ball shape, weight 465 grams, throwing distance 30 to 40 meters. Germany uses the DM51 from 1956 to today. They invented the stick grenade in 1915. They perfected it in 1924. They produced 75 million of them, and now they buy ball grenades because NATO requires it. Meanwhile, China in 2025 continues to produce the Type 67, same form, same physics, same German principle from 1915. The estimate, China has produced about 100 to 120 million Type 67s from 1967 to 2025. That surpasses German M24 production by 50%. A copy of a copy surpasses the original, not in innovation, but in endurance. Let's talk about modern usage. Where are stick grenades still used today? Myanmar, Civil War 2021 to 2025. Government troops use Chinese Type 67s. Rebels use homemade copies. In Afghanistan, the Taliban, they still have thousands of Type 67s from the Soviet era, still fully functional after 40 years. Along the Pakistan-India border, both sides are using Type 67 variants. And North Korea, well, they're estimated to have 20 to 30 million Type 68s in storage. Syria. Various factions there are using Chinese exports. Sudan, South Sudan, Somalia, Nigeria. The Type 67 is everywhere. 110 years after the German invention. The technical specifications, they've barely changed. The M24 from 1924, 35.6 centimeters in length, 600 grams, 40-meter throwing range. The Type 67 in 2025, 33 centimeters, 450 grams, 40 meters. The physics are identical. The lever is identical. German engineers, back in 1915. They found the optimal form. 110 years of evolution, and it changed almost nothing. That's the ultimate confirmation. If a design lasts for 110 years without fundamental change, it was right from the start. But there is a modern twist. In the 2000s, several armies started developing modular grenades. Take the French Alcitex OG-107. It's a spherical body with a detachable stick. They use the sphere for compactness, add the stick for range. The best of both worlds. Now, this isn't exactly new. The Germans had the Nebelgranate 39 with an attachable stick. The Soviets had the RGN-RGO system, but these modern versions, they're more refined. Alcitex advertises 40-meter range with the stick attached. Without the stick, it's compact and easy to carry. What they don't admit is that this is the same German principle from 1915, just with modern marketing. Here are some facts about global production. The M24, the original German one, 75 to 80 million made, from 1924 to 1945. The RGD-33, the Soviet copy, 6 to 8 million, between 1933 and 1940. The Type 67, the Chinese copy, 100 to 120 million, from 1967 to 2025. The North Korean Type 68, an estimated 20 to 30 million. Various other copies, we estimate around 10 to 15 million. So the total production of stick grenades, based on the German design, is between 210 and 250 million units. 250 million grenades, all using the principle from 1915. Now, compare that to modern spherical grenades. The M67, the American one, an estimated 15 million produced since 1968. The DM51, German, 10 million since 1956. The L109, British, 5 million. The RGD-5, Soviet, 50 million. The F1, French and its copies, 30 million. So the total production of spherical grenades around 110 to 130 million. Stick grenades outperform spherical grenades in total production by almost 2 to 1. Why? China, 100 million Type 67s alone. Now you understand the full story. Germany invents the stick grenade in 1915, a physically superior design, double the throwing range, leverage applied. The Soviets recognize its superiority and copy it in 1930 as the RGD-33. China copies the Soviet copy in 1967 as the Type 67, producing 100 million over 58 years, exporting them worldwide. North Korea, Vietnam, Pakistan, Africa, the Middle East, everywhere you look, you see the Type 67. Everywhere you look, you see the German design from 1915. Meanwhile, Germany itself, they don't use stick grenades anymore. NATO standardization, it forced them to use the spherical DM51. The irony is perfect. They invented the best hand grenade in history, produced 75 million of them, lost 2 wars. Others copied their design, produced 250 million. Germany now buys spherical grenades back. They're paying for inferior technology because NATO requires it. That's the ultimate example of taking Nazi technology. It wasn't just America. The whole world took it. Only Germany doesn't use it anymore. These technical truths, they aren't just history. They're physics, leverage, throwing mechanics. Every time a soldier in Myanmar throws a Type 67, they're using German engineering from 1915. Every time the Taliban in Afghanistan uses stick grenades, they're confirming that the Germans were right. Physics is universal. Good designs endure. 110 years is the proof. If you appreciate this technical documentation, if you want to understand how German engineering shaped the modern world, consider using superthanks. This research is extensive. CIOS reports from 1945, Soviet archive documents released in 1991, Chinese production statistics, Aberdeen test reports. These aren't random numbers. This is documented history. Your support helps to preserve these truths. So let's look at the final analysis. Why did the stick grenade survive for 110 years? 3 reasons. First reason, physics. Leverage means a longer arm, means more throwing range. That's unchangeable. Second reason, simplicity. A wooden stick, a metal head, explosives, a fuse. 4 components. Simple production, low cost, robust design. Third reason, effectiveness. A 40-meter throwing range. It gives a tactical advantage. Soldiers who throw farther, they survive longer. Evolution favors survival. Stick grenades survive. Modern armies, they choose compactness over range. That's a strategic decision, not a technical one. The M67, DM51, L109, all modern NATO grenades, they reach 30 to 35 meters. That's acceptable. But the Type 67 reaches 40 meters consistently. Trained throwers can get 45 to 50 meters. That's 30 to 40% more. In combat, that means you hit the enemy before they hit you. That's decisive. Consider the future. Will armies go back to stick grenades? Probably not. Modular designs like the Alcitex, they're a compromise. A sphere plus an optional stick. But that shows the principle is valid. If you need maximum range, add a stick. If you need compactness, remove it. Germany invented the concept in 1915, 110 years later. It's coming back as innovation. That's not innovation, that's rediscovery. Some final numbers: production cost, the M24 in 1944, that was 0.28 Reichsmark, that's about 2 to 3 euros today. The Type 67 in 2025, it costs an estimated $2 to $3 to produce, identical. A modern M67, that costs $30 to $40 to produce, 10 times more. Why? More complex manufacturing, precision fragmentation, modern fuses, safety mechanisms, but effectiveness? The M67 kill radius 5 meters, the M24 kill radius 5 meters, the Type 67 kill radius 5 meters, the same lethality for a tenth of the cost. German efficiency from 1915 outperforms modern production. A concluding thought. Douglas MacGregor wrote in Taking Nazi Technology. The Allies took more than rockets and jets. They took concepts, production methods, design philosophies, the stick grenade. It's the perfect example. America tested it, recognized its superiority, did nothing. The Soviet Union tested it, recognized its superiority, copied it immediately. China copied the Soviet copy, produced 100 million. Who was right? The production numbers speak for themselves. 250 million stick grenades worldwide, based on a German design from 1915. That's not theft. That's confirmation. The national interest asked, did Nazi technology make America a superpower? Partly, but China used German technology more effectively, for hand grenades. They produced more, exported more, influenced more conflicts. The Type 67 is in 40 countries. The M67 is in 20 countries. The German form won. Not because Germany won, but because physics won. Leverage is leverage. The laws of mechanics, universal. Every time you see news reports about conflicts in Myanmar, Afghanistan, Sudan, take a look at the grenades. You'll probably see a stick grenade design, probably a Type 67, probably a German design from 1915. That is the legacy. Not honor, not recognition, but persistence. German engineering outlasts wars, regimes, centuries. The stick grenade is, in every sense, immortal. 110 years and counting. The question isn't, was German technology stolen? The question is, why does it still work 110 years later? The answer? Because it was right from the start. Physics validates good design. Time confirms it. 250 million units produced? That's the ultimate proof. Germany invented the stick grenade in 1915. The world is still using it in 2025. That is a legacy. Write in the comments, should Germany demand royalties from China for the Type 67? Or is 110 years enough time for a design to become public domain? Is this technical evolution or systematic technology theft? I'm interested in your opinion. Until the next video about German technology that shaped the modern world.